Every era is shaped by its infrastructure, from transportation to energy, from connectivity to cloud computing. Today, AI is defining the next age, making the impossible possible across all industries and across the world, changing lives in moments that matter. The promise of AI is clear, but the infrastructure to make it real wasn't, until now. Introducing the Cisco AI-Ready Data Center, infrastructure built to power AI across hybrid environments. We've once again engineered with an ecosystem of partners for the in-between moment, where today's systems still run the business. Tomorrow's demands can't wait, and ripping and replacing isn't an option. AI will change. Your infrastructure foundation shouldn't have to. Cisco AI-Ready Data Center, built for today, ready for what's next.
Hey, Tom, good to see you.
Hey, Kev, good to see you.
Never a dull moment in AI.
There's so much going on. You know, these AI tools are changing like everything that we've been working on, you know, in the most fundamental way. It's pretty exciting, actually.
It is, it is. Why don't we go inside and talk about it a little bit?
Let's do it.
All right.
Hey, I'm Tom Gillis. I'm the General Manager for Infrastructure and Security Products here at Cisco.
And Kevin Wollenweber, I lead our data center and internet infrastructure group, also for Cisco.
And together, Kevin and I are trying to navigate through this literally tsunami of change that's being driven by AI. So AI is changing the nature of the applications that we use, and importantly, it's changing the infrastructure that powers those applications that we use. And then lastly, it's changing the operating model that we use to support the infrastructure. So lots of change in the wing, and really a lot of that change is coming to a crescendo with the announcement around Project Glasswing. So Project Glasswing was a program run by Anthropic where they gave early access to their new generation of models, and they gave that access to a handful of critical infrastructure providers. Cisco was one of those infrastructure providers. And there's two things about this model that was unique. We had early access to it, and the second is that the model that we got was one that had no guardrails. And so what the results that we've seen have been fairly significant. And here's the way I'm going to describe it, which may not be totally technically accurate, but I think it captures the essence of what's happening with these models. So anyone that's been doing software development would know that AI-powered coding tools are amazing. And where we saw the biggest impact was for new projects. So if you had a relatively small code base, the previous generation of models could understand the product in its entirety, and therefore they could be very, very productive. But when you would apply those models to a complex, mature product like a Cisco switch, a Cisco router, a Cisco firewall, these products often have 30, 50, Kevin,
hundreds of millions of lines of code.
Hundreds of millions of lines of code that have been developed over decades,
Yeah.
right? So these are very, very sophisticated products, and the models would struggle to understand them in their entirety, and that's what's changed. And that is really, really significant because it allows them to look end to end at these complex systems and find these interdependencies where if I twiddle this bit and I change this state and then I move to this thing and that thing and this thing, it creates a vulnerability.
So vulnerabilities that we might not have thought were actually that big of a deal in themselves, as they chain together, they create vulnerabilities which can turn into exploits very quickly.
And you know, Kevin, from my perspective, one of the interesting milestones is we all know that AI is faster than humans. We all know that AI can process more data than humans. This is the first time I've seen AI actually has insights. Our best human minds have been looking at this code for decades, and AI can find things that we couldn't.
Well, just think about it like anything else. If it has access to massive amounts of data, its ability to process through that is more than any human can actually comprehend.
Yeah, and so as a result, the findings of these models, we can't be too specific, but we can say it's significant. It's a step function over what the previous models would be able to introduce. And along with that finding, we have to think differently about how we manage this infrastructure. So you and I have been doing this a long time. And the way it would work is we find a vulnerability, we create a patch for the vulnerability, we make the announcement, we give that patch to our customers. Some number of weeks, months.
Days, weeks, months, quarters, whatever.
Quarters go by, and then the customers would update the infrastructure. All right, Kevin, I always ask customers, what's the longest running piece of Cisco gear you have in production? Longest running without a reboot. And I won't put a number on it, but I will say this. If that switch was a child, it would have its driver's license, right? It'd be going to college and might be thinking about grad school, right? And that was okay in a world where it was difficult to find an exploitation of some of these sophisticated vulnerabilities. Log4j was the beginning of the change, right? Log4j was a vulnerability that hit, and what we saw was almost immediate exploitation of that vulnerability. But now, in this kind of post-Mythos era, the vulnerabilities that were being found, not only are there lots of them, we're seeing activity where these things are being exploited,
I mean, almost immediately.
Almost immediately, right? And because the models are generating the exploit as well as uncovering the vulnerability itself. And so simply telling our customers, hey, you need to try harder, you need to upgrade more often, that is a naive approach. We recognize the scale and the effort associated with running upgrades on inline, high-performance, highly engineered infrastructure. And this is where I think Cisco has taken a pretty big step forward. So we were involved in these attacks against infrastructure going back to Volt Typhoon, Salt Typhoon, right? So we lived through this, and we realized it's not always going to be possible to upgrade daily. That's just not a practical thing. And so having the ability to apply a compensating control to a running switch or a router, this is really something that takes a leap forward in the industry.
Well, and let me double click on that, because if you think about it, if this is a web application, you can push a new update, nobody even knows the difference, and they reload a web page and everything's good. But when you think about a running switch, it's configured to manage tens of thousands of endpoints, and so that box going down actually has a huge impact and a downstream impact. So our ability to figure out ways of patching or protecting without having to bring a device down is going to be critical.
And I think that's the heart of I'm going to argue one of the most interesting tech projects that I've worked on, which is what Cisco would call Live Protect. So Live Protect gives us the ability to apply a very targeted compensating control. It's not a broad brush thing. It's not like you're trying to run an EDR in a switch or a router, right? An EDR is going to do lots and lots of things. I think that would make me very, very nervous as an administrator. This is an extremely targeted control that can say, if this particular process with this hash tries to access this particular file with that ID or hash, block it.
Well, I like how you describe it as like almost a micro firewall rule. It's pinpointing that exact definition of that exact access and blocking that.
Right. So that level of precision has two big benefits. The first is your false positive rate it's not zero, but it's going to be pretty darn close to zero. Like if we get a match on that pattern, we want to put eyes on the glass. The second is that the performance implications of this are hard to measure.
But I think that's one thing people need to understand is we're going to have to think about delivering things in different ways. We have to speed up, but we also need our customers to think about moving faster, patching faster, and actually updating devices and keeping things current.
That's, I'm going to argue, the biggest change. We as your vendor are going to give you the tools to really change the operating model and embrace, let's call them cloud principles, CI/CD. Lots of little tiny changes instead of one big gut-wrenching upgrade that you nuclear harden and then try not to change for as long as possible. So we're going to give you these tools, but we're talking about changing decades of human behavior that can take time. So we're in this together, Cisco and our customers, but we're going to introduce this new operating model. And in fact, actually, we're going to show a little demo of this. So Live Protect is designed to be applied to a switch, a router, a Cisco device, without a change control window, without a reboot, without taking the system offline. And let's actually walk through an example of this. So if you're looking at your mesh, you're going to start with Cisco Cloud Control that's going to give you a global view. Here's my network and here's all of the components on it. Now let's say I want to drill deeper into a data center in Miami, for example. That's going to now seamlessly bring us into the Nexus dashboard where I can see the status of all those switches. So this is an important detail, Kevin, that Live Protect will have reporting at the global cloud control level, but this is fundamentally a change in device configuration, and so any device action is going to happen through the device managers. Nexus dashboard, Catalyst Center, right?
Global visibility, but you're going to have to do local management of the device.
Correct, and we're going to give you the tools to roll this stuff out in a kind of intelligent way, manually. But our design intention here is once you get comfortable with these tools, this thing should have no human in the loop, right? Or be, as close to automated as you feel comfortable. So let's look at a real example. So here's an inventory of my devices, and you can see the systems in red. These are systems that are running an older software version that has vulnerabilities. And one little editorial on this, Kevin, is that when we say, hey, these are security updates, these are real security updates, right? These vulnerabilities are real and they are exploitable. And so, we really need to take this stuff seriously. Now, over on the right side of the dashboard, you're going to see here's the PCERT, or the announcement of the vulnerabilities. Here's the patch that you could apply to those running systems, but that requires a change control window. And so for certain vulnerabilities, we will also introduce a shield. And to deploy a shield, it's as simple as watch this. I go in, I say, yep, this is the shield that I want to deploy on these systems. I push a button, and it might take 10 or 15 seconds to propagate into the system, and boom, you're running. That's
Seems pretty easy.
That's pretty easy, right? And we were at Cisco Live, we had one of our early customers, ServiceNow, that has actually deployed shields in a production system. And they started with 2 systems, 4 systems, and in the few days from when I talked to them to when they came to Vegas, they had a whole data center up and running with Live Protect. Okay, so these frontier models are creating these security and operational challenges, but I'm going to argue that when we get through all of that, we together are going to end up in a better place. But Kevin, let's switch gears and let's talk about the impact that AI apps are having on the infrastructure itself. What's that look like?
Yeah, definitely, because not only are we transforming security and how we have to manage devices and secure devices, but we're having to build entirely new network constructs to be able to handle the large numbers of GPUs and also run all these AI workloads.
And you personally are very involved in that, right? You work with some of the largest AI sort of factories in the world.
Yeah,
right?
and it's funny because a lot of what's been happening in the space in AI in general has been built by the hyperscalers or by large model builders, Anthropic and OpenAI. We haven't seen the mass scale adoption of enterprises yet.
It's coming.
But as we move away from training and as we move towards inference and the buzzword of the day, agentic workflows and everything that's going to happen there, we're going to see a lot more adoption of people using the models, which means your network has to be completely reimagined.
And I think, sort of the Cisco opportunity is the learnings that we have from these high-end sort of, very, very large-scale deployments. We're embedding that into the products that we deliver to the enterprise so that as they start to deploy enterprise infrastructure, it's going to work.
Yeah, well, let me explain just a little bit about where we are and how we got here. Because if you think about what a network looks like, we've been building networks for many, many years. Cisco's a 40-plus year in existence company built around building networks. And networks were about connecting things. So we connected storage and we connected compute and we built these large fabrics. Today, that network is largely what we call the front end of the network. And the reason it's called the front end of the network is because we had to build an entirely new network to connect GPUs. So when you think about a back-end network, we're now connecting not only all of the different users and all the different things that you have to connect today, but we've had to build new network constructs. We've had to find ways of connecting GPUs faster and faster to build out large fabrics to be able to build these foundational AI models. And so
let's pick at that a little bit. So this back-end network, the analogy I often think about is that in the first generation with VM-based systems, the PCI bus was the thing that strung together the compute, the storage, networking. And what you're talking about for a back-end network, it
just wasn't fast enough.
Exactly. And it's kind of like a big giant PCI bus, right?
But we had to invent ways of building a technology like that, but at a much, much faster speed because these GPUs are pretty fast.
And we're currently shipping what?
We're building 1.6T, we're building 3.2 terabits, and it's not going to stop.
Everyone knows that GPUs are fast. The network that feeds them has to be faster, right?
And what's crazy is you don't just connect one GPU, you connect many GPUs. Some of these clusters today are thousands, tens of thousands, the biggest ones even being hundreds of thousands of GPUs all connected together.
So when you're in back-end mode, the load balancing algorithms, the kind of core networking principles, they look different than when you're in front-end mode. And I think one of the advantages we have at Cisco is with Silicon One, the programmability allows one device to work in both modes.
And actually the first thing I would say is we've been building large fabrics for many, many years, decades as a matter of fact, and the base technology is Ethernet. I mean, I've been trying to compete with or build competing technologies for Ethernet for decades, and guess
Ethernet
what?
Always wins.
It's still Ethernet. And so the ability to take a base construct like Ethernet, but then add programmability and allow it to do things like different types of load balancing for the front end when we want to connect to storage, or manage and adjust for these elephant flows as we have these massive traffic flows to GPUs. That programmability in the chip is a flexibility that not every device has, and we think is a huge benefit to Cisco.
And this is the heart of our partnership with NVIDIA. Right?
If you think about NVIDIA is the market leader in AI. They've been building out AI infrastructure for, well, as long as AI has been around. But a lot of their focus has been building big training networks for the large hyperscalers. But as they want to shift that into enterprise, as we want to start to move to agentic workflows and inference workflows, being able to build infrastructure in a simple, easy-to-use stack that our enterprises can deploy is something that Cisco is really focused on. And that's why that partnership with NVIDIA makes so much sense, is taking their AI technologies and bringing it into enterprise.
So in partnership with NVIDIA, an enterprise customer can use one set of networking hardware, one management capability that can handle that front end, which is the network that we know and love for decades, and this now back-end network of GPUs talking to GPUs.
Yeah, and it gets even more complex than that, because we started out building a bunch of servers in a rack and connected those together with what we call a scale-up network.
Yeah.
And then you fill out that rack, and what do you have to do?
Yeah.
You have to scale out and connect devices across.
Yeah.
As we build more and more racks, we build these massive data centers, and the data centers aren't big enough to house even the number of GPUs we need.
It's unbelievable that we're at that state, but like this is really happening, right?
Yeah. And so now we actually have a whole new concept called scale across, where you take these big data centers and you connect those data centers together.
Yeah.
And so one of the big values that Cisco brings in these is we can build large fabrics that scale across data centers. We build the optics that can connect them together. And having all of those different components, but being able to put them together in a simple way that customers can understand and quickly deploy, is the only way we're going to get AI pushed deeper and deeper into enterprise. All right, so that's been exciting. We've completely transformed security and how we manage and operate networks. We've completely transformed the network to get ready for these AI workloads. But one of the biggest complaints we hear, or one of the biggest black boxes, is what's happening inside of the application, and how do we get visibility into the applications themselves?
Kevin, we talk a lot about the platform effect, and I think this is probably the best example of that platform effect. The way the industry has evolved, there's a fabric that understands a VM and can do segmentation for VMs. And then there's the Kubernetes stuff that's totally managed separately by a different team with different capabilities, and yet many applications have a VM for a database and a kupod for the application logic. So how do you bridge these two? And I think this is what Cisco does really well, is by integrating Cilium and that isovalent technology into the Nexus dashboard, we provide one comprehensive panel that can see VMs or containers both as first-class citizens.
So as the networking guy, as networking extends into the applications themselves, we can now see that, and it doesn't just stop at the network.
Yeah, to the network administrator, a Kubernetes pod looks like a blob. It's just one big IP address. Now we can expand that blob and be like, no, this is the different services that are running in the application. And so not only can you troubleshoot across Kube and VM-based applications, you can enforce policy. So an obvious one is PCI compliance, right? If you have a PCI requirement, we have to segment the application. We can segment the VM and the containers all from one panel, right? It's a beautifully integrated solution, and it gives you that level of visibility. Now, this same platform effect allows us to solve what sounds like a trivial problem, but it's not. As customers start looking at migrating their VMs out of a VMware environment into, say, a Kubernetes environment, what VMware does incredibly well is it allows one VM to talk to another VM without any knowledge of the physical infrastructure underneath. And that's what enables vMotion. You can move up running a host from one machine to another, and all the network traffic follows, okay? Now imagine I want to move that VM into a Kubernetes cluster. Well, Kubernetes was born in the cloud, so it only has a layer 3 networking model. And so what we've done is, using Cilium and this software capability, the same thing that we integrated into the Nexus dashboard, we created a layer 2 to layer 3 bridge, and it allows you to move a VM into a Kubernetes environment using KubeVirt, power up that VM, and that VM can reach back and talk seamlessly to all of its buddies back in vSphere.
It's kind of ironic, but if you think about the genesis of Cisco, it was connecting devices like that couldn't communicate. So it's just the next evolution of that.
In software,
yeah.
But yes, exactly right? And so this allows customers to begin a slow and thoughtful migration from legacy environments like the vSphere environment into more modern Kubernetes-based infrastructure. Now, to power all this, the server hardware is also changing, right? So when we think about these AI-based applications, you talked about this earlier, those GPUs, those are not small systems, right? Do you want to touch on some of the hardware that is available from the Cisco?
Yeah, definitely.
UCS?
And you need the flexibility to deploy at any one of those levels of scale. Because the interesting thing we saw is training forced us to deploy tons of GPUs. So we built massive systems and massive clusters, but as we're pivoting towards inference, we're actually seeing more and more CPU again, along with the GPUs. And so the ability to kind of have different systems that fit the right profile and then be able to kind of mix and match and put the right things in the right places is something that requires that whole stack approach.
Well, and just to your point, the right thing in the right place, there's no better example of that than the Cisco Unified Edge. Because these AI applications, they don't just live in the data center, right? They're going to live in the world around us. And so having the ability to put a scalable compute platform in a hospital environment, on a factory floor, in a retail environment.
That's the exciting thing for me, right? Is if you think about it, we're in this agentic era, but the physical AI era that's going to come, when AI kind of, I say, moves outside the walls of the data center, moves into robots walking around us, you know, the Waymos and the cars driving around.
My robot bartender, it's happening. I've been like, my whole life, I've been waiting, it's finally happening. And so after decades of experience here, we approach this with a solutions view. And I think that's kind of where we see the industry going. And I know you and I talk about this a lot. Customers don't want to build data centers out of individual boxes and piece this stuff together. Customers are looking at buying data center by the rack.
And the reality is there isn't one vendor that builds all of these different pieces, hardware, software, and everything else. And so partnerships are going to be critical to enabling this.
You know, if we just scroll back a little bit and think about hyper-converged infrastructure, the one thing that wasn't really converged was the network and the network services, because it was too hard to do. And so I think Cisco's in a unique position because the network is our domain, and firewalls, load balancers, we bring all of that to bear. And you can buy this today in the form of what we call pods, right? So we have AI pods where you have the GPUs, the compute, the network, the storage, all glued together. And then we have specific versions of these pods that we're tuning to Cisco applications. So we have a Cisco pod to run Splunk, right? And we have Cisco pods for running AI defense. So delivering these integrated solutions and making them easier to use, this is really our focus. And a step forward in that direction is stack automation, where we partner with Quali, right? So what customers are looking for in these integrated rack level solutions is one click, kind of that cloud level.
Yeah, it's a cloud-like deployment. So it's one thing to understand the network and the stack underneath it, but then how do you actually deploy it in mass and stamp it out into individual components? And so the pods give you the hardware blueprint. What stack automation gives you is the ability to roll these out and deploy them and just stamp them out in many, many instances.
Okay, so we talked about automating the data center. We talked about the sort of every flavor of hardware that's necessary to power all this stuff. The other big change that AI is driving is the way we think about securing applications is fundamentally different. In very simple terms, think about an e-commerce application pre-AI. It's very deterministic. You click on a link, you know what's going to happen, right? A bunch of things are going to happen. With a chat interface, you ask a question. You could ask the same question twice and get a slightly different answer. So our security controls need to evolve to keep pace with that. And Cisco's AI defense is the capability that kind of speaks and understands AI. So we can look at that chat interface. We can look at whether it's a human talking to a prompt or whether it's an agent talking to an API, and we can define this is what normal looks like. And then if we see something that deviates outside of normal, we're able to flag that and stop that. And AI defense is a product that you can buy standalone. But what I think is even more powerful is built into Cisco Secure Access. It is being built into our hybrid mesh firewall, which we're building into the fabric of the network, the platform effect.
Yeah, when you talked about Mythos earlier, you talked about guardrails. It's really those things that sit around the models and make sure that they're not misbehaving.
And what I think is another advantage for Cisco here is we have the full life cycle. So we can red team the stuff before it goes out. We have the ability to put libraries and hooks to secure the models or the agents themselves. And then at runtime, we can look for deviations outside of normal. So it's a whole new set of controls, and it's being built into the fabric of the network. Now, that foundation starts with physical security. Secure boot is something we've been doing for a long time, right? Signed signatures. Bringing post-quantum capabilities into our networking. What's the update on PQC?
Well, I mean, it's going to be available on all of the modern devices we're shipping. And the reason that's important is if you start to think about where quantum's going and the immense amount of compute capability that's going to be in these quantum devices, we're going to have systems that are capable of securing themselves against attacks in the future that don't even exist yet.
Yeah. And so as we think about bringing security into the network, I'm going to argue that there's no better example of this than firewall. In fact, Cisco has really reimagined the whole firewall concept. Instead of having a box at the edge of the network, imagine we could create this in software and place little tiny baby firewalls everywhere. When you have that level of granularity, it allows us to do fundamentally different kinds of security controls. So how this manifests is we have a full line of hardware appliances. We have the ability to push firewall rules into a switch, right? ACI, right? Or ACLs. We can push these policies into Tetragon or Selenium agent that's running in the host. And one of the more interesting capabilities is with our hybrid mesh policy engine, we have the ability to push these rules into third-party firewalls. So if a customer is looking at doing a migration from a competitor firewall onto this Cisco platform, because of the integration, because of this distributed architecture, it's not a rip and replace. And that's huge for customers because it can be very difficult to let go of firewalls you spent 6 years deploying. So rather than rip them out, we age them out.
Yep, and we need new tools, right? If you think about everything we've been talking about so far, security's changing, so we have to have more visibility. So we've got to think about how we apply policy and how we enforce policy around the network in a completely different way. And so this is a tool to be able to do that.
Now, one of the most interesting enforcement points, in my view, in this mesh is the smart switch. And the way to think about a smart switch is it's a single device that has two personalities. So we've got a network processor that's moving packets from A to B, and then a security processor. In the data center switches, we use a high performance, a DPU, but in a campus or an ag layer switch, we don't need all that. We'll use just Intel cores or ARM cores as required. So security and networking living side by side, life cycled independently, right? So you can update that security thing without changing the software on the network forwarding, but it's a single device. And I think this is really a capability that has taken the market by storm because people are realizing, I don't need to hairpin traffic out of my fabric into some third-party firewall and back.
That's potentially going to be a bottleneck at the amount of bandwidth we're driving through these data centers.
Bottleneck, complexity, cost. Kevin, hairpins were really cool in the 1960s for hairdos, but if you're a network administrator,
you don't need them that much anymore.
Dude, I never did. Yeah, the hairpin is a thing of the past. And so this is another example of Cisco's view of the platform, taking multiple functions and just making it much, much easier to use. So Kevin and I love talking about this stuff, but it's always more interesting to hear about this from a customer. So I'm gonna do a throwback to Cisco Live, and we're gonna hear from Davin and Dan talking about this technology in action.
Yeah, so I'm Davin Kamara, so I'm the Group Vice President of Cloud Infrastructure Engineering, so I lead all the networking, data center, and physical hardware teams at ServiceNow. We spend an inordinate amount of time patching hardware all year round. Again, we run across, we're over 30 data centers worldwide. We're a large infrastructure that we operate today. Patching takes a lot of time. Also, when we're looking at the vulnerabilities that are coming out today, some of the ones that just got released recently, it's not, hey, look, we have, like what we said before, you have 20 days, 30 days before people start, you're seeing activity on these vulnerabilities right away. So we're looking for ways of being able to mitigate this immediately. So we're live with Live Protect on one of our largest data centers here right now and running right now for exactly that, to be able to mitigate quickly, to be able to get that fire off that edge and be able to then patch. And again, we're an operation that has full automation for patching. It still takes us a long time to do code upgrades.
Yes, but I want to reiterate something you just said. So you're in production and we give you a shield and you deploy it. What happens?
Nothing.
Nothing.
Yeah.
Right? Get that? That's the whole point here, is we have the ability to put these pinpoint controls in place and it doesn't disrupt your system.
Yep, again, I've said it a couple times, IP and port-based security is dying. It is a dying approach. If we're looking at defense in depth, I love that I can have defense within the container, on the VMs, on the physical infrastructure. I want more layers of that. So it's in our lab right now. We're toying around with it and dreaming up how can we best build our infrastructure with those defense layers. But yeah, the smart switch is a great tool to be able to use for those enforcement points.
Yeah. Awesome.
Davin, I'll say this to you and your team. We couldn't build this stuff without folks like you that are willing to take chances and help us make this stuff a reality. So thank you so much for doing that.
Thank you. Good job.
Well, Kevin, you and I talk about this tech all the time, but it's really awesome to hear a customer like Davin talking about how this is changing his day-to-day world with our stuff, right?
Yeah, and it's fun to watch them really leaning into it and getting benefit from it quickly.
They've been a great partner for us, helping us to develop all this. Okay, there's one more topic I want to talk about, which is the AI miracle that's happening all around us. So blur your eyes for a little bit and imagine if all the complexity of your application, every little tiny interaction in the data center, every east-west communication, if we had that level of visibility, we could identify anomalies far, far more accurately. We could identify problems far more accurately. The black box would be broken open and revealed, right? AI makes this possible. So that data exists. It's Cisco equipment that moves all that traffic from A to B. I'm going to argue 3 orders of magnitude more data than is being ingested today. And this is really the power of the combination of Cisco plus Splunk. So the idea here is rather than dumping all of that data into one gigantic monolithic data lake, and instead of having a single data repository, we have multiple smaller local data repositories. So let's move the analytics closer to the data and not the other way around. So we move from one data lake to lots of little repositories. We index it locally, and then we share those indexes with Splunk. So Splunk becomes the mothership that can see all of this, but it allows us to have observation at that process level. And so when we think about something like the telemetry from firewalls, firewalls are generally the #1 source of telemetry for a SIEM. They can be a third or half of the total ingestion. So we announced a program 2 years ago. We said, you know what, if it's a Cisco firewall, that's free. But you know, Kevin, what's better than free ingest?
No ingest.
No ingest. And so we've announced that we've taken this federation capability, we built it right into the Cisco Firewall Manager. So you store that data locally, you index it, and you actually don't have to ingest it. And it's not just firewalls. This is the magic of the Cisco platform, is we're embedding this into all Cisco products. So the Nexus dashboard, right? Think about NetFlow. Customers would love to be able to look at NetFlow. It's just way too voluminous to be able to examine it.
But thinking about ways we take Cisco technologies like Splunk and embed them across all of the other properties you're using so that the look and feel and usability of every tool we build is the same, makes it easier for customers to adopt.
The other way our customers experience the platform is with a single unified cloud-based capability that we call Cisco Cloud Control, where you can see the basics, inventory, status of my devices, what do I got running? Cloud Control makes this possible.
Yeah, and we've been talking a lot about the impact of AI on our infrastructure and what we have to build to enable AI, but this is really how we build tools to change operations, and then we can use AI to make you more operationally efficient when you're running the network.
Well, now, one of the features that I love in Cisco Cloud Control is AI Canvas, where it's a multi-party capability. So it's really powerful for troubleshooting. Let's imagine an application starts going slow. If you're the app owner, whose fault is it? Always.
It's always the network.
The network, right? So, and if you're the network guy, you're like, oh, it's the server guys. And so with AI Canvas, we have the ability to do a generative UI. So we'll pull the necessary telemetry, and we can have all the interested parties working simultaneously to troubleshoot these problems.
Well, just real quick, a generative UI, like our integration used to be go get a bunch of engineers and deal with APIs and manage views across. Now the system can actually generate the UI that you need to troubleshoot that piece, even if it never existed before.
You know, once customers get their hands on it, you know, the only response is wow, because it's going to solve problems in, you know, a level of efficiency that I think is going to be really astounding.
Today, we're going to look at a global bank who has a critical application that begins to slow down. Normally, that means multiple teams, multiple tools, and really an investigation that can stretch into hours while the users feel that delay. But this time, we're going to take a look at what happens when you task a deep reasoning agent and have it lead the investigation. So it starts with Cisco Cloud Control. So here you see an admin for the operations center logging in and immediately sees an alert initiated by ServiceNow. The fraud scoring service is now experiencing degraded performance. With one click, we're able to open AI Canvas, which is a shared workplace where people, agents, all investigate side by side. So here we see that transactions are still completing, but latency is elevated. So now it's time to investigate. Now we see AI Canvas's reasoning agent lay out its plan. It's going to test the 2 most likely fault domains in parallel, which are networking and compute. And we want this to be a collaborative experience, and we want to get those experts in early. So here we invite the network and the compute admins and give them full context so they come in with zero re-explaining. And now we're going to use Intersight to check for compute saturation. AI Canvas then sees that both hosts and GPUs are coming back clean, so obviously compute is not the bottleneck. With our isovalent integration, AI Canvas is able to look into the application layer. And that application layer is shown to be healthy, as well as the application itself. The DNS is fine, but there are some TCP retransmits that are starting to climb, so the problem must live within the network. And here the agent begins checking both networking platforms, and the Nexus Hyperfabric confirms the fabric is forwarding normally. So then we move on to the Nexus dashboard, and this is where the problem is discovered. It discovers that there are tail drops happening on that leaf switch serving that fraud scoring service, where QoS is not properly prioritized. So AI Canvas recommends a fix to reclassify that traffic into a dedicated low latency class. And now the fix is pushed, and what used to take hours is done in minutes. That is Agentic Ops and Cisco's platform advantage.
Kevin, we've talked a lot about the power of the platform, and here's a simple way I think about it. We're taking advanced technology like AI defense, and we're integrating that into network security devices like a firewall. And then we're taking that firewall and we're integrating that into the fabric of the network with a smart switch. And then we take that network fabric and we integrate it into the compute with AI pods, and then we wrap it all up with the Cisco Data Fabric and Splunk for observability and security. These kind of integrated solutions are going to let our customers do things that, 10 years, 5 years, 3 years ago, 3 months ago wasn't even possible, right?
Yeah, and you would have to integrate all these tools together yourself. And so having a single platform that brings all these together so the customer has one place to go that they can see, operate, and manage all those different areas is something we haven't had before.
Yeah, so the AI tidal wave is upon us. And Cisco is the only company that can bring together the AI infrastructure to power these applications, the advanced security to secure the applications, and the agentic operations to run that infrastructure in a really unique, efficient, and powerful way. Thanks for joining us.